This library has to get more attention, and the reason for that is because it really eases the process of working against databases when you'd like to have a database alongside your application in Python. So we are going to get into the peewee library. We are going to explain what ORM is, because peewee is an ORM library, and of course we will show some cool examples how this library could be used and how easily you can interact with any kind of database that you like to, SQLite, PostgreSQL or MySQL. Let's get into it. ORM stands for Object Relational Mapping. It is a programming technique that enables data conversion between different types of systems using object-oriented programming languages. In Python, ORM simplifies database interactions by allowing you to use Python classes and objects instead of writing raw SQL queries. This abstraction layer makes working with databases more intuitive and aligns with Python's object-oriented principles. With ORM, complex SQL queries could be translated into simple functions, and it allows developers like you to focus on writing Python code, and this also saves your time because you don't have to be superb at SQL to write complex Python applications like websites with Django or Flask. And so now that we understand what ORM is, then let's visit PyCharm to start writing some code that will help us to understand how easily we could interact with databases using the peewee library. Okay, so we are inside PyCharm and we are going to go ahead and start with import peewee as pw, and that will be the library that we know that we are going to use. And obviously it requires running pip install peewee before we go ahead and write our code. Okay, so now we could go ahead and start understanding how we instantiate a connection with a database. So if we go ahead and say pw.database, you can see that we have all the options in this library: SQLite, PostgreSQL and MySQL database. Now we are going to show how SQLite database connections are working right now, and we are going to go ahead and create an instantiation here, and then we will just insert the database name that we like to have. And I'm going to name this example.db like the following, and that has to be obviously saved under a variable because it's an object that we are going to relate in the future. So I'm saving it under a variable called db. Okay, so right after we have done this, then we need to start writing our classes so that later on these classes will represent tables in our database. Like we know, this is the magic of ORM. So we are going to go ahead and say class person, and we are going to leave it as it is for now. And then we could go ahead and use here some assignments of fields that we like to have in our table or in our class if we talk in Python's language. So we could go ahead and use name equals to pw.charField, and we could give a max underscore length here for each name that we will maintain in the database. And also let's say that we like to save the age for each one of the people. So we could say pw.integer field, and we could close our brackets like that. Okay, so now that we have done this, then each class needs to understand that it belongs to a table that is just going to be created under example.db. But currently we don't have any indication about that. So first of all, our class must inherit from a special class that comes within the peewee library, which is called pw.module, like that. And a module basically represents a table in the database that we are going to create. So we have to inherit from this. So now that we have done this, then we still miss the information about how this class is going to know that it should be translated into a table in the database. So there is a convention in peewee to do so. We just have to go ahead and say that we'd like to add some meta information on this model. And we do that by writing class meta right under our original class. And here we are going to assign the database object to a known variable that peewee knows to work with. So if we say database equals to our database object, then it's going to be enough for the model to understand that it's going to be a table under example.db. And that will be the way doing that. Database is a known variable for this model. Okay, so now we are going to bring in our terminal and we are going to start preparing our database file. So for that, I'm going to go ahead and use my Python console by saying Python, and then I'm going to go ahead and I'm going to import everything from the run file that we have created. So it will be from run import, and I will use the asterisk sign, and then we have to understand how we create the database file now. And if we go now to our second tab, then it's still in the directory of the project. Then you can see that I only have the run.py file. Now, if I go ahead and call the db object, which I have imported from the file, and I say connect, like the following, then it is going to go ahead and create the table for us. And you can see that the file is right there. And now we also need to understand how we create the tables under the database. So we have two options. If you were to have multiple modules, then you could go ahead and use create_tables and pass in a reference to all your classes under a list. But that is not our case. So I'll delete everything from here, and then we could say person.create_table like this. And if you remember, person was the class that we were using. Perfect. So now we want to open our database visualization tool to really see how our file looks like. So I really enjoy the SQLite Viewer web application that I have downloaded from Microsoft Store. Or if you're using different distribution, then I really recommend SQLite 3 browser. I'll link this in the description. So I'm going to open our file here, example.db, and you can see that we have a tables person like that. This is how our database looks like. And currently we are looking in the person table here. So for sure now we want to go ahead and create some objects. So it is going to be as easy as bringing again our Python console, and we could start creating some objects. So I'm going to go ahead and say p0 equals to person, and name could be a Paul, and we could pass a random age like 40. And then we could just go ahead and say po.save, and that will ensure creating a row in our database. So if we go to here and we say, you know what, if we just say F5, then you can see that it's refreshed. Then you can see that now we have some information. And we could also modify existing objects, right? If we say po.name equals to Chris, and now we say po.save, then we could refresh, and you can see that it has been renamed. We could also add more objects. Another interesting option would be obviously deleting this row. So it will be delete_instance like that. And if we go here and refresh it, you can see that this row has gone. So these are some of the nice actions that you can go ahead and start already preparing your databases and go ahead and create some objects for whatever application that you're building. Now, before we move on to the next database type, I really want to give a tip for those that are writing large applications and are probably going to have a lot of modules in their applications. So say that we have one more application here, module. So I'm just going to simulate that quickly by having another module named pizza, and I could have a description of the order and also a price. So I'm going to change this to pizza order, and the max length could be a 500 in that case. Now you can see that we have sort of a duplication of code here and here, right? So the way that we could avoid this, according to the documentations as well of this library, is by having a base module of our own that will inherit from the pw.module, and our real modules could inherit from the base model that we have just invented, that we have just created. So it's going to work like the following. We are going to go ahead and say class base module, which will inherit from pw.module, and then here we could define all the metadata that we want on our modules that will be automatically reflected for all our modules if we were only to inherit from the base model. So now we could take this part and paste this in here, and in the future if we have more metadata to add, excuse me, I forgot the colon here, then we could do this here. So if we remove this and that, and we change the inheritance to base model, then it is still going to be the same, but now we earned the ability to control all the metadata on all of our modules in the application, and we are doing it from one place, which is the base model. Alright, so now that we understood how peewee library works, then let's take a look how easy it's going to be to shift this project from working with SQLite to working with a Postgres database. Now obviously we have to have some sort of PostgreSQL database on our hand, so that is why I prepared this notes.txt file for you, so you can go ahead and execute one of these commands to create a quick container with either Postgres or MySQL databases. So if we quickly go over the first command here, basically it creates a PostgreSQL container with that name, and it also assigns these three environment variables because we have to mention them for connecting to our database, and it also exposes this port, which is the PostgreSQL port, and also we persist the data by having a volume attached to it. And finally, the last value is the name of the image that Docker will search to download from Docker Hub. Obviously I have a lot of Docker tutorials on my channel, so if this command looks not familiar to you, then you can watch my Docker getting started video. And so we are going to paste this in like the following, and we are going to run it. And you see that it's going to start downloading the PostgreSQL image. Okay, so if we scroll down a bit, then you can see that it launched the container. And if we zoom out a bit here and clean everything and say Docker PS, then you can see that our my Postgres container is right there. Alright, so now we have to go ahead to our run.py file and see how we are going to update this code here. So we are going to go ahead and say the following. Besides using SQLite database, then obviously we are going to refer to PostgreSQL database and instantiate a new instance like that. And you can see that now we have to start passing in some important pieces of information in order the PostgreSQL database class to understand which database we are connecting to. So first of all, the first argument that we should pass in is the name of the database inside the PostgreSQL engine. Unlike SQLite 3, engines like PostgreSQL could include multiple database instances inside the Postgres application itself. So we need to specify the name of it, and if you remember, we just called it Postgres. And then we are going to specify our username. So it's going to be user equals to Postgres. And we are also going to mention the password, and that is going to be password 123 like we wrote here in the notes, okay? And then we are going to go ahead and specify two more important pieces of information. We are going to go ahead and say that the host is basically local host because the container is running on our network, on our computer, and also the port number, is equal to 5432, okay? And of course I just took these from the lines of terminal code that I wrote here. These were the attributes that I gave to my container to run it. Okay, so now that we have done this, then we are going to test if that's going to work for us. Alright, so now let's go ahead and do Python. So we go inside the Python console, and then we can run from run import asterisk like we have done previously. And if you remember, db.connect as a method with parentheses was responsible to create the tables earlier on. But now if we run it, then you can see that we receive an exception that says Postgres driver not installed. Well, that happens because peewee has some sort of dependencies that it has to also download if you consider using Postgres. And if we consider using Postgres, then we have to go ahead and download the built-in library that supports interacting with Postgres with Python, which is named a bit weird, but it's named copg2, something like that, and we are just going to go ahead and install it. So right in our system interpreter, because we did not use a virtual environment in this tutorial, then we are just going to complete our actions. So I will allow myself to open a new tab here, and again I will select WSL and I will visit my YT directory and then room 1. This was the directory that I was using, and then I'm going to go ahead and say pip install psycopg2.binary, like that. And now that we have installed this, then the only action that we are going to do here is exit Python and repeat our actions. So if we go ahead and exit and we clean everything and we again say Python, then we are going to go ahead and say again from run import everything, and then we are going to run db.connect. And now the connection with our database is established, so now we could also verify that we really could access the database and start creating our tables. Now you might be curious about a tool that is similar to the SQLite tree viewer. So for PostgreSQL you have PgAdmin that you can go ahead and download, and I already downloaded the version that supports my operating system, Windows, so I will link this in the description so you can also go ahead and download. So here's how the PgAdmin application looks like. It is really helpful for viewing all the information about your databases in PostgreSQL databases. So let's go ahead and visit this console here and try to establish a connection with the database that we have just created with a container. So we are going to go ahead and create a server group that we could name something like my home servers. And right after that, we could go ahead and say that we'd like to create a new server. I think this is from the add new server button. Okay, so you could select which server group you want to. I will just use my home servers like that. And I will name this tutorial container. This is just a generic name that you give to it. And in the connection, I'm going to provide everything that is necessary. So this is localhost, like I said, and the database is Postgres, the username is Postgres, and if you remember, the password is password123. So I'm going to do a small trick here. I'm going to write the password so it will be visible for me, so I won't make any mistakes, and I will just cut this part and paste this in here like that. And the port is okay, and that's it. So if we save, then you can see that we did not receive any errors. So this means that it works correctly. Now under the tutorial container PostgreSQL database, then we are going to go to our databases, and you can see that we have a database named Postgres. And under schemas, you can see that currently we don't have any tables, because if we go to tables here, then you can see that we don't have any results. But the second that we are going to create the tables, then we are going to see some results. And it's going to be the same list of commands like we executed with the SQLite tree. So we are going to take the reference of our classes. So it will be person. And going back to our terminal, we can say person.create_table and run it. And also we could do this for the other class that we came up with. So if we go to terminal, we can say pizzaorder.create_table and run it. And now if we go back to our PgAdmin, then we could right click and refresh. And now you can see that we have two tables. One is named person and the other one is named pizza order, like we expected. And now you can take all the actions of creating new objects, and this will mean creating new rows, and that is very nice to see with the peewee library. The fact that you don't have to change your code too much for interacting with multiple databases is not something that you can take for granted. Alright, so going back to our notes.txt file, now let's simulate the same very quickly with MySQL. So if you remember, we said that we'd like to create MySQL container as well, and you can see that the pieces of data here is quite the same. Although it doesn't make sense to name the database name PostgreSQL, so I will just quickly change it. MySQL, and I will name this dash, or without dash, just MySQL1, and I will name the user as well MySQL1, something like that. I will leave the password same. You can see that the default port, the known port for MySQL is different. It's 3306. So I'm just going to grab this command and I'm going to go back to our terminal and I'm just going to run it like that. And it is going to try to download the MySQL image and then create a container from it. Okay, so our container is ready. If we say docker ps, then you can see that we have 3 containers. If we zoom in, then you can see that we have a container created a few seconds ago named MySQL container, and it's up and running. So now what we have to do is quite simple. We could go to our run.py file and we should simply change the class name to MySQL database. It's going to be very similar to what we have done earlier on. It's going to be MySQL1 if you remember, and the user is also MySQL1. We could verify this quickly, and then we could go here to the port and change this to the desired port 3306. And now that we have done this, then it's also a great time checking if that's going to work. Now, a spoiler, it's going to again recommend us to installing a root library that is required, like we have done with the PsyCO library that we installed earlier on. So let's go ahead and see this in action. So if we go to Python, and again we say from run import everything, and we try to db.connect, then you can see that it says MySQL driver is not installed. So what we are going to do in the second tab is installing the MySQL driver. And with MySQL, it is named pip install. And the package name is named PyMySQL like that. And now that we have downloaded this, then we are going to restart our Python. So it's going to be Python from run import everything. And then if we will try to again run db.connect, then you can see that we have great results. And like previously, I could bring up the previous commands with the up arrow and try to create the tables. And you can see that as long as I don't receive any errors, then it means that we have created the tables successfully. So again, quite easy changing between different kinds of databases. And of course, I'm going to link down in the description the tool that I recommend for inspecting MySQL databases, which is a nice graphical user interfaces for MySQL databases that you can go ahead and download if that is your desired engine for running databases. Okay, so this will close out our video. So peewee library is very wonderful for connecting to any database that you would like to, and it is very easy to use as you see. If you enjoyed it here, please hit the like button to spread this video into more Python developers, and consider subscribing for more cool videos like this. I will see you in my next tutorial.